Hello everyone, for the third part of the data structures video. In the previous two parts we have discussed that the data structures are classified into primitive data structures and non-primitive data structures, and we are discussing about the non-primitive data structures, where non-primitive data structures are further classified as linear data structures and non-linear data structures. In the second part of the video, we have discussed what is linear data structures and non-linear data structures. Today we are going to see the different types of linear data structures. We have four types of linear data structures. First one is arrays, second one is stack, third one is queues, and the fourth one is linked list. First we will concentrate on array, which we have discussed in our PU first year classes also. What is array? We will see its definition. What is array? An array is a set of homogeneous elements. An array is a collection of or set of homogeneous data elements. What do you mean by homogeneous? Homogeneous in the sense all the data values or the data elements are of same data type. Means if one value is of integer, means all the values belongs to same data type, integer, so then it is called as integer array. If one value is of character, then all the values are character, then it is called as character array, which is also called as strings, which we have studied in our previous classes also. How actually an array looks? We can see this image. So this is an ordered collection. Remember this part, it is an ordered collection. Linear means it is an ordered collection. In the image we are seeing an array of 5 elements. The element 1 is 2, which is stored in number of 0th position, which we are going to call it as lower bound. That means it is the first value. Then the next value, after storing the 2, will go for the next value, that is number of 1 position, that is element 2. Why this difference appears here? The element 2 is stored in 1 because the lower bound started from 0. The element 1 is stored in 0, and the last element, fifth element, is going to be stored in fourth location, that is size equal to size minus 1. Why this difference appears? Because the value, the first value starts from 0. These things, array, we have studied array in the PUC first year classes also, and we are going to discuss it later also. But we will see the next second one, the second linear data structures. The second type of linear data structure is stack. Now the question arises here, what is stack? Stack is an ordered collection of items. See here, stack is an ordered collection of items. Array is also an ordered collection of items. Array is also an ordered collection of items. Stack is also an ordered collection of items. Then how stack differs from array? There is a difference. We'll see it further. We'll read it from the screen, in which items may be inserted and deleted. Inserted means adding value to the array. Deleted, that means removing an item from an array, is done at one end, called the top of the stack. Then it is called from where we can add and from where we can remove, that is from the top of the stack. In the image we can see here, this is the image of stack, where we can observe there is a stack here. The first value stored in the stack is 1. The second value stored is 2. Added, stored means added. This operation is also called as push operation. Adding an value to the stack is called as push operation. Then the third value added in the stack is 3, 4th, 5th and 6th. Okay. Then which is the last value added to the stack? It is 6. This is the last value, and where it is stored? It is stored in the top position. And we said here the values are added to the top and they are removed from the top. So pop means removing an element from the stack. Which is the first element removed from the stack here? It is obviously 6. After removing 6, then which value will be removed here or deleted? Obviously it is 5. Then which value? Then 4. Then what? Then 3. Then 2. And then 1. And like this the stack goes empty, because it follows one principle. I told in the last class it follows one principle. What is the principle? Last in, first out. Last in, first out means which is going to be added in the last, that is going to be taken out first. The best example for this principle is bangles. A lady wearing, a girl wearing a bangle to her hand. Suppose, imagine that she is going to wear 5 bangles. First bangle, second bangle, third bangle, fourth bangle, fifth bangle she has inserted, or you can say she has put in her hand. But the question arises here, which bangle she is going to take it out first? Obviously, which she has put it at the last. At the last, the bangle which she has inserted at the last, she is going to take it first. That means fifth bangle she is going to take it first. The next fourth, the next third, the next second, the next first, and after removing the first, all the bangles has removed from her hand. Now you can say the stack is empty. Like this the stack works. Further we are going to discuss about stacks in the later part, but we have seen on the screen that in the linear data structures we have arrays and we have stacks. How it differs? Where is the difference between array and stack? Array is also an ordered collection, but it goes in the forward direction. Number of 0, number of 1, number of 2, number of 3, while adding also, while reading also, will come from the lower bound to upper bound. Here also in the stack will come from the lower bound to upper bound, but the values are removed first from the top, that is from the upper bound. We have seen 2 types. Further we have 2 types here, that is queues and linked list. We will see the next one, that is queue. What is queue? What is queue? The first, what is the definition for queue? What is the definition for queue? An ordered collection of items in which, see here, it is also an ordered collection of items in which items may deleted at one end, called the front of the queue, and items may be inserted at the other end, called the rear end of the queue. In the image you can see, we can understand queue very easily. Queue, a people of queue which is standing in bank counter. You can see a queue in the bank counter. When you go into the bank, when you are seeing already 4 persons are standing in a queue, then you will stand at the last, or you will stand at the first. Where you will stand? You will stand at the last. That means you are the 5th person standing in the queue. If the first person has taken his cash, his work is finished, he has deposited or he has taken withdrawal, then he will go out. Then the second becomes the first and you become the 4th one. When the second has been removed, the third becomes the first and you became the third. When like this queue continues, because in the queue the values are removed from the front end, the process of removing is called as dequeue. The process of removing, this person has gone out like this, so this is called as dequeue. Whereas the process of adding an element, you can say, that is called as nqueue, and from where it is added in the back, that means rear end. So this person is added in the back, that is in the rear end. So this is what we are going to call it as Q. We have one more linear data structure here. This is called as linked list. This is quite different from these three, because these three things we understood it easily, that we have an array which is an ordered collection. Stack, yes, it is also an ordered collection, but it follows principle. What is that principle? Last in, first out. Last in, first out. Q is also an ordered collection of items, but it follows one principle, first in, first out. What principle is followed by the Q here? The principle followed by the Q is FIFO. What do you mean by FIFO? That is first in, first out. That is that is Q. As I said, linked list is quite different. We'll see its definition first, and then we'll go to the further discussion. What is linked list? A linked list is a linear means ordered, same. A linked list is a linear collection of nodes. It's not only items, it has one node. Then what is that node and what it consists? Okay, we'll see here. We'll see an image here. There is an image of a linked list. In this image you can see, there is a node called A. See this A, this is head, A node. It is divided into two parts. This is divided into two parts. This is divided. Each node is divided into two parts. The first part contains the information of the element, and the second part contains address of the next node. See here. The first part contains information. The information stored here is A. Then the next, it is address of the next node. So, the address of what? B node. So, this is address of B node. And the B node contains the address of C node. And the C node contains the address of D node. So, this is, and the very important thing, the last node here, okay, the D node is assigned with null, means this is the end of linked list. So, the linked list consists nodes. The node which is divided into two parts, in which the one part consists the data and the second part consists the address of the next node, means where the next data is stored. Okay, we'll see what is linked list in detail later onwards, but we have to concentrate here. There are four types of linear data structures. The first data structure is array. The first linear data structure is array. Then the second one is stack. The stack follows which principle? Last in, first out. LIFO, LIFO, last in, first out. And the third linear data structure we are having here, queues. The queue follows which principle? The queue follows first in, first out. Then the fourth one we are having here, linked list. But linked list has nodes, where the node is divided into two parts. One part is having data and another part is having address of the next node, means the next data, where the next data is stored. So, this is linked list. Okay, now we will go to the discussion of the next slide, where we are going to discuss about arrays. We will see all these four things, but first we will start from array. We have to study arrays also, we have to study stack also, we have to study queues also, we have to study linked list also, but we begin our linear data structures from arrays. Now, the question arises here, what is array? First we are going to define. An array is a set of homogeneous elements. Fine. You can define it in other words also. How you are going to define it? An array is an ordered collection of data of same type means same data type. As I said, integer means all are integer only. Then the next question is, name the different types of arrays. What are the different types of arrays? One dimensional array, two dimensional array and multidimensional array. In the previous year, in the PUC first year also, we have discussed about one dimensional array and two dimensional array. In the second year also, we are going to discuss about one dimensional array and two dimensional array and its operations. That is quite added thing in the second year, PUC second year classes. Okay, but next we will go for the next slide. Explain one dimensional array. Basically, we are going to study about some basic things about array. How we are going to explain one dimensional array. Okay, then first we are going to define it, and array is finite. Okay, then we are having an one dimensional array can be defined as, I given its general syntax here. The general syntax is, okay, data type, then array name, then array size. Defining an array is very similar to defining a variable. You can see here in the example, int marks. The data type is integer. The array name is marks. Then the array size is how much now? 6. The array size is how much now? 6. The size of the array is 6. That means marks is not only one integer variable. It is a 6. It is a variable which is going to store 6 integers. That means 6 subject marks we are going to store in one array, one integer array called as marks. This is how we are going to define an array. Then the next one is, next question arises here, how we are going to input an one dimensional array. We can input one dimensional array by using looping statement and scene statement as follows. Okay. So what is the looping statement we have used here? Int I equal to 0, I less than 6, I plus plus. Why I have taken 6 here? You can take size also. Why I have taken 6? As I know that I am going to input only 6 subject marks, that is maximum. So the lower bound starts from 0, that's the reason I value I have given 0, less than 6, that means 5 only. Then I plus plus, that is an incrementation every time. Then how we are going to represent its memory, how actually it is stored here. Okay, we will concentrate on the for loop also, memory representation of one dimensional array. You can see an array here. Okay, now basically we are discussing here when I equal to 0, okay, now in the beginning I equal to 0, then where the first element is stored, marks of 0, the first element is stored here, marks of 0, we have given 98. Then the second element, marks of 1, then the third element, marks of 2, then the fourth element, marks of 3, fifth element, marks of 4, then the sixth element, marks of 6, because upper bound is equal to what? Size minus 1. What is your array size here? 6. So 6 minus 1 is equal to how much? 5. 6 minus 1 is equal to how much? 5. The size I have given here 6, lower bound is 0 and upper bound is equal to 6 minus 1, that is 5. Okay. Then how we are going to output? So very similar, how the way you have inputted an array, in the similar fashion we can output one dimensional array by using looping and cout statement. You can see here I equal to 0. When I given I equal to 0, then marks of 0 means 98 is going to be displayed on the screen. Then I value increments. I value increments now. What happens? I value becomes 1. When it becomes 1, then marks of 1, that is 87 is printed. Then I value becomes 2, then 94 is printed. When I value becomes 3, then 94 is going to be printed. 4, then 81 is going to be printed. 5, then 86 is going to be printed. Then when it becomes 6, when I value becomes 6, then 78 is going to be printed, and we know that that is the last element. Marks of 5, that is the last element. This is how we are going to work with arrays. Okay. So these are the things which we have discussed in the PU first year classes also. But in the next class, what we are discussing here, these are the things which we are mainly going to concentrate in the second year classes, few second year classes. What are the operations on one dimensional array? So these things I have discussed in my previous or the second part of the data structures video. The common operations on arrays are traversing. What is traversing? It is the process of visiting each element in the array. We will write an algorithm for this one, and how to traverse an array we will see. Traversing means just visiting an array elements from lower bound to upper bound, from 0 to size minus 1. We have to visit each element and we have to print it on the screen. That is traversing, very easy algorithm. Then the next one, insertion. Imagine that we have an array of 5 elements and we want to insert a new element to the array in the middle or in the end or somewhere. So that process is called as insertion. What is that process? It is the process of adding new element to the existing array is called as insertion. Similarly, deletion. It is the process of removing an item from the existing array. How the way we can add an element to the existing array? In the similar fashion, we can delete an element from the array. That process is called as deletion. Then the next one is searching. It is the process of finding the location of a given element in the existing array is called as searching. We have to search a number. Sorting, as I already told, we can arrange the data elements of an array in some logical order. Then what are the logical orders we have here? It may be ascending order or it may be descending order. Fine. So these are the operations on one dimensional array. See, in the last video, in the operations of data structures, we have listed merging also. That merging means combining two different two data structures, we called it as merging. You can see here we are not listed because we are going to study or we are going to have an algorithm on only these 5 things. First one is traversing. What do you mean by traversing? Visiting each element in the array, that is called as traversing. What is insertion? It is the process of adding new element to the existing array. Deletion, removing. Searching, that is finding. Sorting, arranging in some logical order, that is ascending order or descending order. Okay, fine. We are going to have first operation. I request each and everyone to concentrate on this part. It is an algorithm. In the 5 marks question section, we know that we have 11 questions. In 11 question, we have one fixed algorithm. We know what are the algorithms we are going to have. Traversing, we have an algorithm. Insertion, we have algorithm. Deletion, we have algorithm. On searching, we have 2 algorithms. Then we have an algorithm on sorting. Nearly on 6 algorithms, we are going to get one algorithm compulsory. So that's the reason I request each and everyone, all my few students, to concentrate on this part. The question arises here, what is traversing? As we know it from the basic, traversing is the process of visiting each element. Then what is its how its algorithm? Its algorithm will be like this. Start, okay. Then we have an array here. Okay, we'll start from for loop. We'll concentrate here. The for is started from 0, and where it is going to end? It is going to end at size minus 1. So if I value is 0, then we are going to print a of I, isn't it? Print a of I. Okay, we'll imagine that I value is 0. First we'll see I value is 0. When I value is 0, what happens? When I value is 0, then first a of 0, that is 10, is printed. Then what happens now? I becomes 1. If I becomes 1, what happens? The 20 is printed. See, we have shifted from a of 0 to a of 1. We have already visited 10 and then now we are visiting 20. Now I of 2, every time the I value is incremented. So this is visiting. This is visiting, and this process of visiting and each element in an array is called as traversing. What happens now? It comes to the 3, then it comes to the 4, because total size of an array is 5, but the upper bound is going to be 4 because the lower bound we have started from 0. 0, 1, 2, 3, 4, 5 elements. 0th element is 10, first element is 20, second element is 30, and then 40, and then we are having 50. So, this process is called as traversing an array. This process is called as traversing an array. Okay. So, thank you. Today we are going to have this much only. In the next class, we are going to discuss about insertion, which is very important concept.